Okay, so looking at day 9 in Unit 5, so we're looking at inverse trig functions. So a couple of things here that I want to make sure that we know. Whenever they refer to y equals sine theta, okay, the inverse of that would be sine to the negative 1 of y. So, like if we have y equals cosine theta, if we're talking about the inverse of this, then the inverse would be cosine to the negative 1 of y equals theta. So if you remember inverses, the symbol is always negative 1. So this just tells us that a function has an inverse if and only if the function is 1 to 1. Remember, 1 to 1 means it passes the vertical and horizontal line test. And then the graph of the inverse is always a reflection of the diagonal line y equals x. And then, if you remember, for inverses, the domain and range are going to flip-flop for the inverse. Okay, so because we didn't actually go over trig graphs, we didn't do day 6 and day 7, this will be a little different than we normally do. But if you were to take a look at the graph of y equals sine x, the graph would look like this shape right here. Okay, you've looked at sine and cosine graphs before, but this is just a portion of the graph. So this portion of the graph right here, it does pass the vertical line test and it passes the horizontal line test. So this part of the sine graph would be considered a function. So if we were to look at the inverse of this, okay, which is what we're going to be focusing on, is y equals sine negative 1x or y equals arc sine x. Those mean the same thing. If we were to do the inverse of this, that means it is reflected across y equals x. This is what the graph of y equals sine to the negative 1x looks like. So, with what we're going to be doing and the problems we're going to be solving, the important part is the range here. So, whenever we are looking at, whenever we're doing problems that are the inverse of sine, and it can be written like this, or it can be written as arc sine x, those mean the same thing. The important part here is going to be the range. So the range for inverse sine or arc sine is from negative pi over 2 to pi over 2. So looking at the graph we have here, range is the y value. So the lowest number it can go to is negative pi over 2, and the highest it can go to is pi over 2. These are going to be called our principal values when we start actually solving these problems. So that's going to be super important. Okay, so now we're going to move on to cosine x. So guys, if you were to just graph the regular cosine x, this is just a portion of the graph here. So we're going to be focusing on the inverses today. So if we have y equals cosine to the negative 1x or arc cosine x, those mean the same thing. The important part that we're going to want to focus on is the range there. Okay, so when we're working with the inverse of cosine, the important part that we're going to have to focus on is the range. The range here, so looking at your y values, it can go from 0 to pi. And then this will be called our principal values. Okay, the last type that you have to worry about is arctangent. So tangent graph is at the top of the screen there. But we're going to be looking at the inverse of tangent, so it's reflected over y equals x. So this is going to be our graph here. So once again, the important part that we're going to need to focus on for our problems is going to be the range. So we're working with the inverse of tangents, which can also be written as arctangent. The range. Now, on this graph, the range is a little bit different. So there are actually asymptotes, horizontal asymptotes here and here. So it doesn't actually ever touch negative pi over 2 and pi over 2, so that's why it has parentheses instead of brackets. And these are called the principal values. Okay, the reason this is going to be important, because in a minute we're going to solve problems that work with inverse trig functions. And when you're doing inverse trig functions, you can't use the entire unit circle to get your answers. You can only use the principal values to get your answers. So, what this means, when we're going to do an arc sine problem, because this goes from negative pi over 2 to pi over 2, if you take a look at a unit circle, so here's a unit circle, so 0 to pi over 2 would be here. If we were to go backwards, then negative pi over 2 would be in this fourth quadrant. So when we're doing sine and arc sine values, we're only going to be able to look in quadrant 1, or we're going to be able to look in quadrant 4. And when we look in quadrant 4, we're going to have to do some editing to that when we finish. Okay, so then if you look at cosine, it can go from 0 to pi. So when we're doing inverse of cosine, we can look in quadrant 1, or we can look in quadrant 2, and we won't have to do anything special there. Tangent, arctangent is very similar to arcsine. They're both negative pi over 2 to pi over 2. So we are going to be looking in quadrant 1 and quadrant 4. But because arctangent has the parentheses, that just means it can't be on the endpoints. So it can only be between. So you can kind of think about them the same way. But so we're going to be looking in quadrant 1 or quadrant 4. When we get to quadrant 4, we'll have to do something special to make it in between this interval. Okay, so next we'll be solving a few problems.